So guys, in this video we will try to understand the complex mathematical functions using the multilayer perceptron. So let's see how we will structure a complex mathematical functions using that MLP. Okay, so first let's consider a complex function. So here I am considering f of x is a mathematical functions, and it's like look like this. It's that suppose I am considering here, suppose sine x square plus root over of 5x. Okay, this is a complex mathematical functions I have taken here. As your requirement, you can take any functions, but for an example, I have considered this. Okay, these functions. Now, how we represent these mathematical equations in the form of a multilayer perceptrons. So, let's see. First, let's try to identify what are the input here. Okay, let's try to identify it. What are the inputs? So here variable is what? Here first input. Understand. First we have to understand the input here. So first, what is the inputs? Input is that first x is that independent variable, first input, and two constants are there. It's the input and two constants. Two constants are there. What are the constants here? Two constants. Two. Here we have these two, and one constants. Another constants we have here the 5. Here is that input is x and two constants. So you can think like a constants here, you can think like is a bias terms, nothing else. So don't be confused about that. Now let's structure these complex equations in the form of a multilayer perceptrons. How it look like. So before going to that part, we have to identify what kind of functions required here. What kind of simplest functions here required here to represent that equation. So let's first try to identify what are the required functions. So first function, if we consider this is a one part and this is the another part of that equation. So first functions we required here the summation functions, guys. So first functions we have required, I have taken here f1 is that summations, or you can think like it's the adding functions. Okay, second functions what we required, if we consider this part, so then we required here to that square functions. Just I am taken here the different color. Yes, this color is okay. This function is that called that f2. F2 is that square function. Okay, next what functions we required for this term? Suppose let's I am taking here this color here, this different color, these functions. This function here, what is that? This function is called that this is whole function is called that square root function. So sorry, this whole function is called the square root. In short, SQRT I am written here, square root functions. Next, what functions we require for this one? Suppose for this one, sine functions also required. Sine function I am written here, this function is a sine function we require, and also we require that for this multiplications 5x 2 into something 2 into sine square x for this one, so we require another one functions. Let's I am calling here this for this, and for this we have another functions we require. This is called f5 and this calls the multiplication functions. So this total, to make this diagram, to make this MLP means that the neural network or that multilayer perceptrons, we require these functions, these 5 functions. Now let's represent these equations in the form of that MLP. How we will represent the things? So first, what are the inputs? First, let's try to write the input first. So here our input is x and two biases, two constants here. So 2 and x, 2 and 5 are the constant terms that we require. So first, what do we have to compute? So let's first we have to take this one and this one. Okay, so first if we just make this one, first we require that x square. So for make the x square, what functions we required here? Let's make it small. We required for x square f2 functions we required here. Okay, and output will be what here? Output will be the x square. After getting the x square, what functions we require, guys? We require the sine functions. Here we require that functions, which function is called f4 functions, and this output will be what? Let's make a flow. It will be the sine of x square. Okay, now after getting the sine, just first I am computing this one, sine of x square. We required a multiplication function. These multiplication functions we required for making the what? 2 into sine x square. So we required the multiplication functions. So multiplication functions is our f5 functions, and these functions which produces, and one input we required here to make that. This is the 2 constant term we required here, and here these functions is f4, then this function will produces 2 into sine x square. This function will provide this. So again, one functions we required here to, now we have to produce this 5x. So this 5x we produce. So again, one input we require, this one and this one, with multiplication, with the help of the multiplication functions, means f5, we will produce here what? We will produce here the 5x. Okay, 5x. Now using the 5x and the square is to f3, again we apply here the f3 functions, and we will produce here the 5x. Okay, now we will produce these two. Now again, one functions we required here. These functions we required here for additions, means that it's called that f1. And finally, if we just taken the output of the functions, output will be what? This output will be 2 sine x square plus x. That's the simple representations. These things are called that our input. This is that called that output layer. Just like take a different color. And the internal connections are called the hidden layer. And guys, you can see here, it's not the connections here. So you can see here, between these two are not connected, these two are not connected, these two are not connected. So means that it's not a fully connected neural network. It's not a fully connected neural network. When we record, we make the connections. So the same thing, such same job also we will do for a complex problem. Our main job is to, based on this output and input, we have to predict these connections, where we have to make this connection, where we have to delete the connections. So simply by, if you just make the simplify of that structure, it's a not fully connected neural network. Okay, so here is that connections we require. Here it's simple, because we have not required the any weight. It's here, all the weights are here 1, all the weights are here 1. But when we require, we have to predict the weight also. That's depend on the, but for this simplicity, for this, so for making the structure of these equations, we not require this weight term. Okay, this is the simplest structure of the simplest structure of the multi-layer perceptron. I think you will understand from this equations point of view. Okay, how we will, and uh, how you will structure these mathematical equations in this graphical way of that multi-layer perceptron. And one thing, guys, I want to tell you, this multi-layer perceptron is the graphical representations of that one. but these equations also we can represent it in the compositions of that at the mathematical functions. Lot of these math, if we make the compositions of these mathematical functions, so we can also represent this thing. So from here we can analyze is that, so multi-layer perceptron is nothing, it's that the compositions of lots of functions, lots of layer. Okay, so multi-layer, if you just make that simplifications, multi-layer perceptrons in other way, it's that compositions of lots of functions, composition in simplicity, compositions of functions. So let's try to understand. This is the, I think you will understand how we will make these connections, what are the how we will make the structure of the, it is a graphical point of view. Now let's try to understand how we will represent those things in the point of view of a functional compositions. Okay, let's try to understand it. So first of all, what we require, we will take on these equations. First we will represent these equations in the form of a mathematical function. So if we just make this one, and 2, let's take a different color, 2 sine x square. So first what we require, so first of all we required here the, we have to make the x square first, we have to make the x square, and how will make the x square, x square is the f2x, f2 is that square functions. If we make the x2f, sorry, f2x, then it produces the x square. Now f2x we have taken as the input, and we will want to produce the sine x square. So f2x is what, f2x is at the end of the day, f2x is x square. Now we have to use the sine function. Sine function is where, here sine function is f4. Okay, let's f4 here. So f4 into these terms is called that sine of x square. Okay, now we will take, let's make different color, we take the whole thing as the input, sine x square, and want to produce a functions 2 into sine x square. Okay, if we want to produce a 2 into sine x square, then one input also we required here. For this 2 we one input we require, so for 2 and this 2 sine x square, and we apply on top of it another functions is called that multiplication functions, that is called that f5, multiplication function, yes, f5. So this whole thing is, we can write it as a 2 into sine x square. So I think you will understand how we will represent the whole thing 2 into sine x square in these compositions of the mathematical functions. Now let's make that another compositions of the another part, root 5 x square. Similarly, as pause this video and let's try to make it as yourself. How will, first we have to make that 5x. So if we make the 5x, then we will require two input, one is 5, one is x. We will require these two input, and on top of it we have to apply the multiplication functions. What is the multiplication functions? Is like here the multiplication function is 5x. So what will be this one? This will be out, give the output 5x. Now using this all the things as a input, okay, 5x we have considered, and we have applied on top of it that square root function. Square root function is what, f2 functions is our square root functions, f3 functions. So on top of it we will apply here the f3 functions. So then we can consider here the all the things is equals to root 5x. Okay, this is our the final two one. So if we just make, now finally what do we require? We will require that 2 sine x square plus root over 5x. So for these equations we know what will be this one, and this one is for this one, and for some functions we require this two one. So I will call these all the things. I will call all the things is a high 1 and I call all the things as a high 2. Now final equations we can write it as a some functions, we have to add functions, f1 functions. So f1 will be our high 1 high 2. So instead of using phi 1 you can write all the things and phi 2 or write all the things, then you got that one. So this is that one another structures of the the multilayer perceptor. So all the multilayer perceptor, all the MLP you can write the all the things in that way also. The things is similar to that what f1 I1 I2 same thing. So in another language if we just can't make the conclusions here, so what will be the conclusions? So in another language multilayer perceptrons or a simple neural network is nothing but it is that compositions of lots of functions, compositions of functions. Compositions of function using different weights. We will introduce here the weight function is here. Here the weight function is there, the simple one for making the simplicity. But in the real world this is not always one. There are lots of weights. Okay, different weights are there. So our job is to predict that weight, that as we have previously seen. Compositions of functions using different weights. Okay, that's the simplest thing. I will from this example, from the using of these complex mathematical equations, you will something little bit you will understand the structure of that MLP. What are the internal thing, how it will work, and how the things actually represent the things. Using that example, I think you will little bit you will understand. If you have any doubt, any confusion, just comment below. I am always here to help you. I will try to give my best, as simple as clear way. I will try to give my best to understand that the more complex thing in easiest way. Okay, so in next video we will see how to understand the notations, how we will identify that complex thing, and how to represent the equations for edge layer, edge input layer, output layer, hidden neuron, is the things, all the things. What will be the notations, is thing we will see that thing in the next video. So till now, bye.